talk about. We touched on it last week, but the law of reflection states that the angle of the incoming light and the reflected light are always the same. Or equal. The same or equal. Always. But this only works, again, when we have a smooth mirror. When it becomes bumpy, we call that diffused, and it's not the same. It says here that the incoming ray always forms what we call the incident light ray. And the reflected ray always forms the reflected or the reflection. Makes sense? Now, let's look at this diagram. This right here is a diagram of what this actual picture is showing me. First thing is, I see that this is a nice, smooth, flat surface mirror, which is this mirror right here. Now, I have this invisible line. It's dashed, and it's not really there. We call this the normal line. The normal line. Over here at this image, it's not there. It's fake. It's a line that we make up. The normal line is always 90 degrees or perpendicular to the surface. So come quiz day, come test day, you're going to need that protractor so you can see where the 90-degree angle is. Okay? What does perpendicular mean? Like math class, it means that this normal line right here always forms a 90-degree angle to that surface. Okay? Now, let's go ahead and let's say that, do you look at this image or this actual picture? The light is coming in this direction. So I can see that the light is coming in at this direction or this angle right here. This is going to be in this section, the angle of incident or theta. What theta? I don't know, but whatever theta it is, it should always be the same theta at the other side. And this section over here, we call it the angle of reflection. But this theta, which so happens to be the same, actually is called theta prime. One more time. It's actually called theta prime. It has a little like comma. It has a comma. So this section over here, one more time, is called the theta or the angle of incidence. This section over here is called theta prime or the angle of reflection. But what I do know is that they are always going to be the same. The light is coming in, the light is going out, and they should be at the same theta. They should always be equal. Why? Because my surface is a nice smooth mirror. So over here, where I actually see my actual picture, I've got a make-believe normal line. Again, it's make-believe, and it's perpendicular to the surface. I've got my angle of incidence, which should always match and be identical to my angle of reflection, or I call it theta and theta prime. So let's go ahead and write it in our notes. The angle of incidence is called our theta. Whatever theta it is, it could be 52 degrees or 61 degrees, I don't know. That's going to be the angle between the ray that strikes in to the surface right here and all the way to the normal line that the surface is perpendicular to, or the line is perpendicular to the surface. The angle of reflection is theta prime. And the theta prime is going to always be formed from the normal line, which you can see from the normal line, to the outgoing reflected line and the direction at which the reflection ray moves to. In this direction, it's going to be what we call the angle of reflection, or theta prime. The angle of reflection, or theta prime. The law of reflection states that my theta is always equal to my theta prime. It says here that the angle of incidence is always equal to the angle of reflection. But remember, this is only occurring in a plain flat mirror that's a nice surface like the video that we just watched. It only occurs in a plain flat mirror like the video that we watched. It says here that in a flat mirror surface that is going to be very smooth and shiny, this light is going to be reflecting off of a flat mirror, which creates the image to appear behind it. This image is called a virtual image. The virtual image is going to be an image that is formed by a ray that appears to come from behind the mirror, but never really does. It doesn't make sense right now. Give me a moment and we're going to go over it in more detail. And then that worksheet that you have, we're going to go over that. One thing I cannot stress enough, the law of reflection only works in a flat, smooth mirror situation. If it's going to have like curvedness, then it's not going to happen. What happens is, I woke up this morning, I didn't have much time, but I did go to the bathroom and I stood in front of the mirror. This is the mirror, and that is the object, the quote-unquote real object that stood in front of the mirror. The mirror is going to produce what we call a fake image, or a virtual image is the real word. It's going to produce a virtual image that is always going to be upright, but it's going to be flipped. It is always going to be flipped. It's going to produce a virtual image, a fake virtual image that will always be flipped. Let me give you an example. I can come over here and I can take a selfie, right? To where my camera is facing me. But when I look at the images and I go back, what happens to the words on your shirt? They are inverted and flipped. Makes sense now? Because look, that is a fake virtual image of that selfie. Yeah, that makes sense. So what happens? What do you have to do when you want to post that image, but you don't want your words to be flipped? You got to invert it. Exactly. That's what we're talking about here. This is super easy cheesy when it comes to looking or making our pictures. So one more time, if it's a flat, smooth, and I don't know about you, but as long as your little camera thingy up here at the top and you don't have a crack in your camera lens, then that's a flat, smooth surface. I can do a virtual image. Is that really me when I look inside the mirror? Or is that really me? No, that's not me. This is me. When I look at a mirror, That is a virtual image of me. That's not really me looking at me. Or when I take a selfie of me, that's not me in the picture. It's a virtual image that is backwards or flipped. Okay? That's what they're saying. It is a backwards flipped virtual image. And that's what we're about to get to in just a moment. A little bit of notes over here, and then we are done with actual notes. We're going to get into the assignment for today. It says over here on the next part that the object distance from the mirror is equal to the distance of the virtual image. Okay, what do I mean? I mean, when I look at my image in the mirror this morning, if I was standing 2 feet from the mirror, that image looks like it's standing 2 feet from the mirror. The image doesn't look like all straight up stuck to the mirror like it's close up. No, it looks exactly at the same distance, equal to what you are standing from the mirror. So for an example, if a 6 foot tall person is standing 2 feet from a plain flat mirror, then the reflection will be a 6 foot person 2 feet from the mirror. Oops. And this will be the virtual image. This will be the fake virtual image. If an object is reflected if an object is reflected smaller or further away, like if a car mirror. Oh, have you ever seen those car mirrors, right? So you've got your side mirrors on the outside, but wait a minute. If you look inside those car mirrors, some of them look like the car is further away, and it's really not. It's kind of like right there. But why? Is that little car side mirror flat? Nope. It's what? Curved. Okay? So now if an object looks smaller or further away, like in a car rear view mirror, then that is not a flat mirror. It has curves, and those curves are going to be what we're going to talk about on Thursday. When you come into class Thursday, your desks are going to have mirrors and lenses that are going to be called concave and convex. We need to get through flat mirrors first. We need to talk about concave and convex, and then I'll let you play with them. Please just don't break them because they're not cheap to purchase them, right? So let's go ahead and talk about what we call ray diagrams. Ray diagrams are going to be diagrams either on flat mirrors or curved images, curved mirrors like concaved or convexed. So it says here that a ray diagram is going to be a drawing that uses simple geometry to locate an image formed from a mirror, okay, or a lens. A mirror, comma, or a lens. Let's say that, because it could be lenses too. So let's go ahead and let's look. This is my mirror. Do you see that it's flat? If it's a flat mirror, it is always going to produce a fake virtual image that will be inverted or flipped. One more time. This mirror is flat, but wait a minute. On the worksheet that we're about to do in a moment, this right here is not flat. Do you see how it's skinny in the edges and bigger in the middle? That's called convex. So right now in our notes, you have to look, whether it's your notes or whether it's the quiz this Friday. You need to look, is my mirror or lens flat, or is it bumpy? Is it curvy? This one is a flat mirror. So I'm going to put here, mirror is flat. In this situation, I'm going to have my real object over here. That's like if you were standing in front of your mirror. You're the real object. But for here, I'm going to draw in the letter R. Go ahead and write the letter R. Nice and big. The letter R. Roar, there you go. So when you are looking at a mirror image of you, you would be flipped. So on the other side, this is going to be the fake virtual image that will be flipped. I agree 100%. But I'm not expecting us to pull out the ruler and come over here and make sure that the other one's the same. That's how you would really do it. You would actually get the ruler and you would come over here and you would measure, okay, my R is, let's see, 1.2 centimeters away from this. You know what I mean? That's what you would do. But let's be honest, just like Carlos said, hey, Miss Munson, if you come over here and you just try to, you can kind of like, Miss Munson, just kind of flip it. Now, don't get me wrong, my R is not exactly the same, okay? I know it's not. But you could draw an exact flipped image. But would it be flipped? Just like on your selfie pictures on your cell phone. It would be a flipped image. Okay? But sometimes we come into situations where we have what we call convex. A convex is going to be curved on an outward curve surface. Do you see right here? Convex. Right here in the middle, it's bulgy. It sticks out. Most of us, personally, I wear contacts. Carlos, do you really wear glasses? Do you really do? Yeah. Well, why don't you have them on? You just like you got really good vision, like you can't see super far when you're driving. Okay, I was going to say, because I know you have those other glasses. Okay, so most of us who wear glasses right now, I have contacts on, have lenses that are convex, okay? Most of us who have problems seeing have convex lenses. This classroom is also shared by another teacher, and he has these, what do you call it, reading glasses in here. Let me see if I can find his glasses. I wore my contacts, so I can't really show you my contacts. I don't see his glasses. For those of you who have glasses, you can pull your glasses really quick off and you can see. And next Thursday, when I see you in next class, I'm going to have some lenses that are like this. They look really cool to look through. If I was you, with my cell phone, I would put it under the camera and take pictures. It looks really cool to look through it. So next class, I'll have this out. So convex. The cool thing about convex lenses or mirrors, actually mirrors, is that they are going to produce a small image that causes the light to be diverge. It diverges the light. It produces a virtual image. And the image, look at this baseball. Do you see that this baseball stitches are up? This is also up. We call this upright, or we can also call it erected. Upright or erected, okay? Both words work. Flip the page over because we need to talk about the other one, and then we're almost done with the notes for today. Okay, The next side over here, we're going to talk about, well, let's continue to talk about convex mirrors. Again, we're talking about mirrors, not lenses yet. They, like I said earlier, diverge the light, and the image is going to be smaller. Let's look real quick. I said smaller image. Look at this baseball. Is it the real same size? No, it's smaller. You can see that it's smaller. Okay? These are mirrors. This one is called concave. Concave is an inward curve surface. Concave looks like this. It curves in. Some of our glasses are like that, but not a lot of people. But there are a few people, when you go to the eye doctor, your glasses that you get are a little skinnier at the ends. That happens too. No worries. Okay? Now, when it comes to concave, you can produce a virtual image or what we call a real image. Now, it's not a real one, okay? It's a fake real one, but we'll talk about those later. It can cause it to be upright, the image, or it can be inverted. What is the word inverted? Upside down. I'm going to go ahead and put that in parentheses. Upside down. Just in case if you're not with me later on and you're like, what does that word inverted mean? It means upside down. It also can produce an image that can be enlarged, like in bigger, or reduced, as in smaller. Okay? Now again, this is for mirrors, and lenses are just a hair different. Okay? Now, I'm going to go ahead and stop with my notes. I'm going to move my notes out of the way. You have a worksheet. We're going to go through part of it today in class, and then you need to finish it later on. This is going to be your homework number 1. It's not on D2L yet because I want to go through all my classes first. Okay? So let's go ahead. It looks like this. It says homework number 1. Let's start on this side. Right? You picked it up when you walked in because you read that little note card, or I apologize. Remember, I wasn't paying attention. That's our note card that we had. I just didn't have it up very well. So here's our thing. Put your name on it. I'm going to put 2026 9:30 a.m. Okay, homework number 1. Now on this page, it's going to be plain flat mirrors on this page. One more time, I can't say it enough. This page only is a plain flat mirror. The other side is not. The other side is not a plain flat mirror. Alrighty, so let's go ahead and check this out. Ha. These mirrors are both going to be plain, smooth, flat mirrors. We can see that. And in our notes, we said if it's a plain, smooth, flat mirror, it's going to have one side is the real object. The other side is going to be the fake virtual, the fake virtual object. And it's not a V-E, it's a V-I. The fake virtual image. Let's use that word because I don't want to confuse us from object versus image. You are the object. When you look in a plain flat mirror this morning, you looked at or you saw the virtual image that was produced. But remember, on a plain flat mirror, it is always going to be flipped opposite. Meaning, if this is the real one, then over here, it's going to look like this. Right? So what I'm trying to say is on the Quiz Friday, I'm going to give you the real object, and I'm going to tell you that it's looking at a plain flat image, a plain flat mirror. Your A, B, C, D answer choice, this would be the correct one. because it's inverted or it's opposite. I'm sorry. It's opposite. It's flipped. It's always going to be flipped. Let's do it again. If this is the real object, my fake object is going to be flipped. Go ahead and draw one, but it should be about the same size as well. Would it be reduced? No. Will it be way bigger? No. Obviously, look, my drawing was not good. Your drawing will probably be better than my drawing. I apologize. But it's going to be flipped. Okay, that's the reason why we have to flip our selfie pictures, because if not, the words are going to be backwards. All right, I guess you should buy a shirt where the words are already backwards so your selfies would be the right way. Ooh, how about that? All right, let's turn the page, because on this side, you need to get that green pen or matte pencil, and you need to get a red. And then you need to use a blue or black ink. So you need red, green, and then blue or black pen or pencil. Okay? This, I guarantee you, is on the quiz. It's going to be on the test, and there's a question also on the semester exam. All righty. So let's go ahead and get started on this. We have 3 lines that we're going to draw. You definitely need a ruler. And over here, I've got boxes. I got a box of matte pencils and pens. If you use a crayon or a marker, it like smudges out. It smudges out. So I do have pens and matte pencils for you. And rulers. Pencils? And rulers. You need a ruler too.
Where's the matte pencils at?
Right here. Or if you want to use that. And look, I even asked Miss Wadding. Thank you, Miss Wadding. She got us a ta-da, pencil sharpener. I just haven't plugged it in the back. I know. So what about a pen? Did you get a pen?
I just need a black.
Oh.
Wait, you said blue, right?
Or blue. Do you have a blue? Yeah, look, here. Here. Yeah, it's better if you use a pen, not a marker. Yeah. Blue or black pen or pencil. Right, something to write with. You definitely need a ruler. Okay, now wait a minute. Let's take a glance at this ray diagram. Is this a plain flat mirror? No, it's got a bulge on it. Question, we just talked about it in our notes. Is it concave or convex? Concave or convex? It is. It's a convex, where it bulges in the middle. It bulges in the middle. Now, what we're going to do is on line number 1, we are going to go ahead and draw out. Line number 1 is going to be for us. Let's do it in green. So let's call line number 1 green. Line number 1 is going to be green. When you turn this in, line number 1 better be green. Line number 2. I know this sounds crazy, but line number 2 is always going to be the bottom number. Let me go ahead and put this with green. Line number 1 is always going to be the top line. Line number 2 is going to be red for us, and it's always going to be located at the bottom. I know, it's crazy. That's how I do my best drawing. I draw it at the top, I draw it at the bottom, and then line number 3 is going to be pen or pencil. I'm going to just write pen, whatever, blue or black. But it's going to be in the middle. It's going to be in the middle. That's going to be line number 3. So we go to the top, we go to the bottom, we go to the middle. Okay? The next important thing to look at this, like you already told me, is that these right here, when I look at this you told me was convex. Oop, V-E-X. V-E-X. This is convex. Okay? It's not a plain flat. Meaning that when I go ahead and produce a virtual image, it could be virtual or it could be what we call real. It could be upright, it could be inverted, it could be enlarged, it could be reduced. I don't know yet, but I'm gonna have to do my drawing so I can figure out what it's gonna look like. The next thing that's super important that we need to talk about or look at is this right here. This dot is called the focal point. The focal point. Now, let's go ahead and let's get into a little bit more. Let me give you an example. This is actually your eyeball that's looking at this arrow. This arrow is pointed up, and you personally, this is my eye looking at it in that direction. Do you see my eyes looking at it? Now, guess what? This actual image, my eyes look at it, and it's going to produce an image in the back of my eye, back here. It's called our retina. And right there in the back of your retina, it connects all of your nerves from your eye, and it goes up to your brain. This is why we're going to go ahead and dissect cow eyes, because inside cow eyes and inside our eyes, we have convex lenses. And our convex lens is going to converge or diverge depending on if you've got good eyes or whether or not you're like me, maybe with astigmatism or something like that, bad vision. And so now your image over here may not be in the right location, okay? This would be the great spot right here, but unfortunately it doesn't always work out like that. Let's go ahead and start off with line number 1, which is always going to be green for us, okay? The way you always draw line number 1 is you're going to get a ruler to help you. You're going to go ahead and always, whether it's number 1, 2, 3, 4, 5, 6, 7, or 8, you are always going to have the first or the actual object. The first line is going to go from the top of the object to the top of your lens, and you're going to stop it right there. So from here to here, as straight as I can make it, I'm going to draw my first line. I'm going to connect it from the top of the actual object to the top of that lens. But guess what? My light is going to go through here, and it's going to touch here. When it touches, it refracts. What does the word refract mean? We talked about it last unit. It's going to bend to another direction. So now it's going to bend. When it bends, it's going to bend from the top, and it's going to bend and always touch and go through the focal point. So now let's connect it from the top through the middle of the focal point. Just like that. Hey, that's some pretty good drawing. Look at that line. This is my eyeball looking at this arrow that is pointing or facing up. The way that light passes through my eye passes in 3 different spots. Then they're going to connect back here to the back of my head or the back of my eyeball. First line always goes from the top of the object to the lens that's inside my eye. It causes the light to refract and bend. And it's going to bend and change directions from the top of the lens through the focal point, and it keeps going back. No worries. Line number 2. Line number 2 is always going to be red, and it's going to be what I call the bottom line. This bottom line is always going to be from the top of my object to the bottom of my lens now. That's the reason why. Does that make sense? Bottom. So let's go ahead and connect it from the top of my object to the bottom. And then it stops. It's going to refract and bend. Now, I'm going to, for line number 2, straighten out my ruler, go from the bottom of my lens, and just keep going back as far as I can, nice and straight. There we go. Line number 2. This is line number 1. This is line number 2, which is the bottom. The top line, the bottom line. Now line number 3, when I draw it in, is always my middle line. And what do I mean by the middle? Do you see how the first one touches the top of the lens? The second one touches the bottom of the lens. The third one always touches the smack dab middle of the lens. Boom, right there, smack dab middle. So what happens is in line number 3, we are going to connect from the top of my object through the middle of my lens. So let's go ahead and let's go from the top of my object through the middle of my lens as much as I can, as perfect as I can. Make that as straight as possible. That's pretty good. Look at that. It's not perfect, but it's pretty good. Not perfect, but pretty good. Okay. Now, perfect would be all 3 lines touch and connect. And that's what they actually do. But because I'm human and I'm not perfect, okay, my red line is not touching. But these 2 are touching. My red line, I'm a little off. That's okay. But it should be up higher touching. Let's go ahead and do this again. Let's go to number 2. On number 2, start off with color green. It's going to be the top one. It's going to go from the top of the object to the top of my lens. Then I'm going to stop and I'm going to refract or bend. I'm going to bend it down through the focal point. And I'm going to come over here and say, okay, let's go ahead now and let's bend from the top of my lens to my focal point in that direction. Line 2. Remember, this is line number 1, which is the top line. Line number 2 is red. It's going to go from the top of my object to the bottom of my lens. And then when it hits the bottom of my lens, I'm going to stop. Why? Because it's going to, let me say the word, refract. Oops. Or bend. And when it refracts or bends, it's going to turn directions, and now it's going to go straight. Do you see that on line number 2, the moment I touched the middle of this lens, I stopped my red line. The moment I pass through the middle of the lens, one more time, is when I stop my red line, and now I go straight. Okay? I probably should have did that at the first one. I didn't do too good at that. I did better on the second one. The third line, pen or a pencil, you're going to go from the top of the object through the smack dab middle of your lens. From the top of the object to the smack dab middle. Somewhere's like that. Oh man, that's some good drawing. Woo! All 3 lines connected. They're still not perfect because I'm not completely straight. You can see that red line kind of went up. I don't like that. I'm not straight enough. But I did better. I did better. That red line should not have been that high up. That red line is a little cruddy. That's all right. we go. That's a little better. See, I kind of went upwards. I didn't go as straight. There we go. Let's do this again. Number 3. On number 3, we're always going to start with line number 1, which is green, then line number 2, which is red, and then line number 3, which is pen or a pencil, which is the middle line. All right, number 1, green. I'm going to go ahead and get my arrow. I'm going to connect my ruler to the top of it, and I'm going to stop my green line when I hit the middle of this lens. And the reason for that is because at the middle is when the refraction, or where the refraction occurs. So I'm going to refract and say, bend from the middle of my lens through the middle of my focal point. That's pretty good. That's some nice drawing. Line number 2, which is red. And if you're already done with this one, move on to the next one. And the next one. You have 5 of them to do. All right? You don't have to wait for me. You can move along. The moment that your red hits the middle of the lens, stop drawing the line and get ready to bend it. All righty? Make sure that you bend it, and when you do, you try to draw it as straight as possible. There we go. And go ahead and continue. You've got this. Line number 2, and then line number 3 is always the middle one. You don't need me. You can do this on your own. Now that I showed you how to do it, ooh. Here we go. Again, my lines are not perfect. I will tell you that where you get at least 2 lines connecting is where the new fake image, whatever, is going to be formed at. All right? Number 4. Let's go ahead and do number 4. Number 4 is going to be as well from the top. Go ahead, connect it. And like I said, if you're already past us, continue to move forward. Don't wait for us. But some of you may be at number 4 and number 5, and you might be a little confused on line number 3 or line number 2. I'm going to go ahead and do line number 1 for both number 4 and number 5. If you're a little confused, no worries. I'm going to go ahead and I'm going to draw line number 1 for both of those. Line number 1. Now I'm at location number 4 and object number 5. I'm going to pause for a moment. Line number 2. Line number 2, if you're on number 4 and number 5, let's pause for a moment and let's take a glance. Line number 2 should be red, and it should be able to come over here, go from here to here, and then cross over. Let's double check that. Line number 2. Line number 2 goes from here to here. You probably did line number 2, but were you able to do line number 3? That's my question. Line number 2, I'm going to call it right here, number 2. Look at number 4. Are you able to do line number 3? Line number 3 should go from the top of the object through the middle and touch the focal point. Could you use a ruler? Could you go from the top of the object through the middle and touch the focal point on line number 3? I don't know about you, but me personally, I'm unable to produce that correct line for line number 3. Line number 3, go ahead and draw it, but it is not correct. I'm going to go ahead and put a little note right here. Not correct. Because it should, it has to, it must touch the focal point. Did it? No. Remember, line number 3 should go from the top of the object through the middle and touch the focal point. Or it should do something, but I don't know. I'm not touching this focal point very well. Look at this. I'm not really, the green line and the black line should always touch. The red line, that's a suggestion. The red line, if it doesn't touch perfectly, we might need glasses. But there's a problem when the black line, the black line, it doesn't have to touch. You were probably looking at me like I'm crazy. Should touch, let me say this. It should touch the green line, let me say that. Go back and rewrite this. Or we can call it line number 1. It's not touching it. I apologize. Wipe that out, scratch it out. It should say this. It's not correct because it should touch the green line or line number 1. And look at that, it's not even touching it. Let's go ahead and do line number 5, or lines for line number 5. We got number 1. Number 2 goes through the top to the bottom. And then after that, it refracts, right here. It's going to refract, bend, and go sideways, nice and straight. Just like that. Line number 3 should go from the middle, from the top to the middle of my lens. And it should touch line number 1. It's got to touch it. Look at that. It's not correct. It's not correct because it should always touch line number 1. There's no touching going on. Remember the red line? That's nice. But it's not as important as my green line and my pencil pen line. Those two should touch. They must touch. It's not touching. Alrighty, so here we go. Let's go back from the beginning to the talk about this now. And then I promise we are so done. Where the green and black line are touching should be where my actual fake virtual image is going to appear. So for an example, right here, if this is an arrow, and do you see how this top of the arrow touches those 3 lines? Here down at the bottom, again, the red line is helpful, but it's not going to be my do-all, be-all. The green and the black, or line 1 and 3, are the do-all and be-all. So for an example, what I'm trying to say is, do you see how this touches right here? This is going to be flipped, and it's going to touch right here. And this is going to be my arrow right here. That is my actual virtual or whatever fake image. That is my image. This is my image. Is it fake? Is it virtual? Is it real? I don't know yet. We haven't got to that part. Let's look over here. This one, whoa, here's black, here is green. It's about right here, give or take. Do yours where yours is drawn out. Mine's on number 2 is not that good. On number 2, my actual object did not work out good. Number 3, whoa, look over here. This is where those 2 lines are touching on number 3. Way over here. And this is what happens in our eyes. When you're doing the eye test with the eye doctor, they are determining where this image is actually being located in the back of your eyeball. But wait a minute. Number 4 and number 5, does the line 1 and line 3 touch? No, they do not touch. There is no image. So let's go ahead and let's do that. I'm going to write here, line 1 and number 3 do not touch. So no image is produced. Let's do it again. Number 5. Line number 1 and number 3 do not touch. So no image is produced. No image is produced. Okay. First thing is, let's go ahead now and go back to number 1. Number 1, look at the image. This side is our image side. Do you see it says it, image? This side is our image. This side over here is our object, our real object. This is our image. Is it upright or inverted? Upright or inverted. Let's look at it. It's inverted. It's upside down. Inverted. Is it enlarged or reduced compared to the original size? Reduced. Is it real or is it virtual? Real is when line number 1 and number 3 touch. So yes. Virtual is when line number 1 and number 3 do not touch. There you go. Is that easy cheesy or what now? Man, Miss Munson, you just simplified this. Sure did. Let's do it again. Upright or inverted? That looks inverted to me. Is it enlarged or reduced? Reduced? Okay. I'm going to pause for a moment. Believe it or not, it should be the same size. It's a little off. Forgive my drawing, but it should be. I'm going to go ahead and put a little question mark, but I'm going to come over here. Should be. Ruler. Ruler. You should be able to come over here with the ruler and look at it. So this one you can tell. If I come over here and measure it, let's see. From here to here, that's a good question, Carlos said. From here to here, it's about 1 centimeter-ishy. From here to here, it's pretty smack dab on here. Yep, it's the same size. Should be same size. So I'm going to leave that blank. It's not enlarged, it's not reduced, but it is going to be a real image because my line 1 and line 3 touch. Do it again. Number 3, I guarantee you quiz. We need to know. Number 3, can you not tell that this sucker is inverted and sucker is enlarged? And it is a real image because line 1 and line 3 touched. But let's do this again. Whoa, is it inverted or is it upright?
Upright.
Where's the image? Oh, it's not there. Image. Image is, I'm going to write the word none. Okay, now there is no actual image here produced, but can I call it real or virtual? That I do have to claim. This one is virtual. This is an actual virtual image. That means that it's a fake image that sometimes, if you believe it or not, you see things that are not really there. That's because inside your brain is smart enough that even though you don't see it, some of the image is missing. If that makes sense, your brain will make the connection and your brain is still going to see something there. This happens in real life to us sometimes. Let's look at the next one. Image is, I'm going to write the word none, but this is actually what we call a virtual image because our brain fills in that connects the dots. We are done. You actually, unlike first period, you got homework number 1 completely done. It's not on D2L because we're going to have another part that goes to